Hello and welcome to Olagold Academy. For today's class, we are considering calculations on linear motion. I've made a video lesson on motion, the types and the calculations. In that video lesson, I also explained or referred to as acceleration, deceleration, free fall, and other things related to that. And in that video lesson, I gave some calculations that we examined on that particular video lesson. For today's class, we are having a continuation on that previous class on motion. So for today, we're looking at calculations on linear motion. Alright, question 1 says that a body accelerates from rest at 0.2 meter per second square for 1/5 of a minute full stop. Calculate the distance covered by the body. A body accelerates from rest at 0.2 meter per second square for 1/5 of a minute. Calculate the distance covered by the body. So let's look into how we can solve questions like that. Solution. As usual, if we see any question in our science subject calculation, the first thing to do is to always list out our given parameters. If we read the question carefully, we are given acceleration because the question says that a body accelerates from rest. Now let's look at the question. It says that a body accelerates from rest. So it means that the initial velocity is 0 meter per second from rest at 0.2 meter per second square. So the acceleration, which is A, equal to 0.2 meter per second square. 0.2 meter per second square. So we have this. For 1/5 of a minute, 1/5 of a minute, we are having 1/5 of a minute, which is 1 minute. So what do we do here? We have to find the 1/5 of a minute. As we all know that 1 minute is 60 seconds. But before then, one thing we know is that the standard units for time is seconds. So we need to convert this minute here to seconds. So we are having 1/5 of 60 seconds. Of means multiplication. So 60 over 1. So 5 here 1, 5 here 12. So we have equal to 1 times 12, we have 12 seconds. We have this. So 1/5 of a minute is 12 seconds. So we have time to be what there? 12 seconds. Let's continue. Of a minute full stop, calculate the distance covered by the body. Calculate the distance covered by the body. Like I said in the previous class, I've also done the derivation of the equations of linear motion. You can check that video out also. Now we have the equations for linear motion. One of them, or let me say the first one, is V equal to U plus AT. The second one, we have V squared equal to U squared plus 2AS. The third one, we have S equal to UT plus half AT squared. And the fourth one, we have S equal to V plus U over 2 multiplied by T. We have these four equations here for uniformly accelerated motion or linear equation. So from our given parameters, what formula is the best to make use of here? What formula is the best formula to make use of here? What formula is the most suitable formula to make use of here? If we check carefully, you can see that equation 3 is the best equation to make use of. So let's recall that S equal to UT plus half AT squared. We have this. Now let's input our given parameters. S equal to, our initial velocity is 0, time is what there? 12. We have 12. Plus 1 over 2. Acceleration is 0.2. Time is 12. So we have 12. But let's not forget there is squared here. So we have square. From here now, let's continue. From here now, we are going to have, or let me use this side here to continue. Let me use this side here to continue, so that I can keep, for me to be able to keep the equations here, so that we can consider the equations together when we are solving. Alright, from here now, I will have my distance to be equal to 0 times 12 is 0. I have this plus 1 over 2 multiplied by 0.2, and 12 squared is 12 times 12, which is what? 144. We have this here. From here now, I can say that 2 here 1, 2 here 72. So I have my distance to be equal to 0 plus 1 times 0.2 will give me 0.2 multiplied by 72. I have this here. I have this. Alright. Finally, my distance equal to 0.2 times 72 will give me 14.4. 14.4 plus 0 will also give me 14.4. And what is the unit for distance? The unit for distance is meters. So I have meters. So I have 14.4 meters as the distance. So this is how we can be about questions like this. Like this. So let me take off this part so we can go into question 2. Alright, let's look into question 2. Question 2 says that if a body moving with a velocity of 3 meters per second is brought to rest by a constant force after traveling 15 meters, calculate the retardation. Let's look into that question. From that question there, what are we given? The question says that if a body moving with a velocity of 3 meters per second, so it means that the body is moving with a velocity of 3 meters per second, and the question says that it is brought to rest. So it means that the initial velocity is 3 meters per second. Initial velocity equal to 3 meters per second. Let's continue. It's brought to rest. Brought to rest means the final velocity is 0. brought to rest 0 meter per second by a constant force after traveling 15 meters. So the distance is what there? 15 meters. Calculate the retardation. So we have to calculate the retardation. And retardation also is a kind of acceleration. So we have to calculate retardation. So we have this as our given parameters. So let's examine these equations together. What formula is the best formula to make use of here? If we check carefully, we can see that equation 2 is the best formula to make use of. So let's input our given parameters. So let's recall that v squared equal to u squared plus 2as. From here now, our v, which is final velocity, is 0. So we have 0 squared equal to initial velocity is 3. So we have 3. And remember, there is squared. So we have squared plus 2. Acceleration is not given. So we have acceleration. Distance is 15. So we have 15 here. So we have 15 here. It is more better for me to bring the 15 here and bring the a here. So we have 15 before a. So we have 15 here, then I will have a here. Any of the arrangement is correct, but it's more proper to arrange it this way here. So let's continue. 0 squared is 0 equal to 3 squared is 3 times 3, which is 9, plus 2 times 15 is what there? 30. And we have what there? We have a. From here now, my next step is to collect like terms. So I'm bringing 30a to this side here. And if this 30a with this positive sign cross this equal to sign, it becomes negative. So we have negative 30a equal to 9. So my next step is to divide both sides by the coefficient of a, which is minus 30. So over minus 30 over minus 30. So minus 30 cancel out minus 30. Right here, 3 can go here. Let's say we have 3 here to be 3 and 3 here to be 10. So acceleration equal to 3 over minus 10. So we have this. So from here, you can have it like this. It will be a equal to minus 3 over 10. Is that like this or like this? I'm still correct. So from here now, my final answer, which is acceleration equal to, if I divide this, I will get minus 0.3 meter per second square. I will have this. I will have this as my final answer. But let's not forget, the question says that calculate the retardation. So if I have to write for retardation, I will have to neglect the negative sign here. So we have 0.3 meter per second squared as my final answer for this question here. So this is how we go about questions like this. Alright, now let's go into the third question, which is the last question for today's class. Alright, let's look into question 3. Question 3 says that a body which is uniformly retarded comes to rest in 5 seconds after traveling a distance of 10 meters. What is its initial velocity? So let's see how we can solve that question. Now let's read the question jot by jot. The question says that a body which is uniformly retarded comes to rest. So the body comes to rest. So it means that the final velocity there equal to 0 meter per second comes to rest in 5 seconds. So the time taken for the retardation or deceleration is 5 seconds. 5 seconds. Alright, let's continue. After traveling a distance of 10 meters, so distance equal to 10 meters. 10 meters. And the question says that what is its initial velocity? So initial velocity equal to question mark here. So we have this. Alright, from here now, when we consider these equations carefully, what equation is the best equation to make use of to get our initial velocity? If we check carefully, we can see that the fourth equation, the fourth one, this fourth equation is a suitable equation to get our initial velocity. So now, let's recall that distance equal to final velocity plus initial velocity over 2 multiplied by t. From here now, the distance is 10 meters. So we have 10 equal to, open bracket, final velocity there is 0. So we have 0 plus initial velocity is not given. So we have initial velocity over 2. And the time taken is 5 seconds. 5 seconds. We have this. From here now, 10 equal to, open bracket, 0 plus u is same thing as u over 2 multiplied by 5. So we have this here. From here now, we can have our equation to now become 10 equal to, opening this bracket by using 5 times u will give us 5u over 2. So we have this. From here, what do? We do what? We cross multiply. So here over 1. If we cross multiply, we are going to get this coming here and this coming here. Or this one coming here and this one coming here. Alright, 5u times 1 give us 5u equal to 20. And from here now, what do? We divide both sides by the coefficient of u, which is 5. So here over 5, and this side here over 5. So 5 here 1, 5 here 1. So 5 here 1, 5 here 4. So our final answer, so initial velocity equal to 4 meter per second. So this is the final answer for this question. So this is how we solve questions like this under linear motion or uniformly accelerated motion. Alright, if you find this video helpful, do well to hit the like button, subscribe, drop a comment, and also share to others who are in need of knowledge like this. Please do well to support this channel by hitting the like button. So thanks for watching. This is Olagold Academy. Thank you.